Uh, so, um, Welcome to our presentation about the two advanced level programs that we offer, Computational Methods in Engineering and Intelligent Automation. Thank you. So to continue with intelligent automation, uh, similarly to the questions related to computational methods, the future of factories, of course, is going to be far smarter, far more digitized. It's going to include far more robotics, and the usage of computerization, decision mechanisms, AI will impact every single stage of the production process, including the design of products, the interaction of the design of the products with the production process, um, all the way through to models and simulations of the entire factory. And then we have to look at the question of optimization for how to use optimization in conjunction with the simulations to try to drive better designs for production or better decisions within production processes. The Intelligent Automation Masters Program looks at all of these different topics. We look at modeling, we look at simulation, we look at optimization, we look at artificial intelligence, mostly in the context of production systems. And we are looking to also validate these manufacturing systems using virtual tools. So this is moving towards the digital twins. So we look at the question of the virtual components and how they relate to the physical components. This can either be at the level of an individual robot or at the production cell level, or indeed up to the production line level. The program is 120 credits over 2 years, exactly the same as computational methods, and it actually shares several courses with computational methods. The first term of the first year includes 5 courses, which are shared between both programs completely, giving a basic foundation necessary for both programs going forwards. The two programs begin to diverge a little bit more through the spring of year 1 and the autumn of year 2. Intelligent automation particularly moves towards the question of usage of AI and virtual commissioning at the level of production lines and robotics. So we have topics such as virtual intelligent machines, engineering optimization methods and applications, and modern manufacturing technologies and applications, which looks at questions to do with how we might integrate large language models or virtual reality into production processes. In the autumn of year 2, we then have artificial intelligence for visual anomaly detection, which deals with questions of using deep learning neural networks for automatically being able to detect anomalies in production processes. We share model-based manufacturing with the computational methods course, and Wei has just been discussing that. We also have courses on autonomous systems, dealing with the usage of AI for robotics, and that looks at the question of autonomous mobile robots within factories, but also deals with certain elements to do with human-robot collaboration, the technologies needed for that. Virtual factories with advanced analysis looks at simulations at either the line or the entire production process level, and how to actually analyze data coming from the simulations. So it's reusing techniques looked at in engineering optimization, but applying to on a bigger, more practical scale. The two courses which Wei has already mentioned, but I've avoided talking about them until the second, the design and development project. As you can see, there is design and development project 1 and 2. So for a full 40 weeks, through the spring and autumn of year 1 and year 2, there will be this large group project activity where you'll be looking to apply the techniques that you're learning in these various courses. And the design and development project is shared between this program and the computational methods program. So the idea is that the teams within those courses will actually be a mixture of students with expertise from both sides of this field, working together on joint projects, which, as Wei said, might be brought in from outside industry or might be brought in from our research projects. And we round out with the final degree project in virtual product realization for 30 credits. The admission requirements are a little different to computational methods. Most obviously, we allow information technology as a background. That's because many of these courses involve programming, artificial intelligence, and the applications more at a high level of software engineering to the control of engineering systems. Otherwise, degrees in integrated product development, production engineering, automation, and mechanical engineering are also accepted. Proof of skills in English, which, as Wei mentioned, will be discussed later on in this presentation. Intelligent automation also has links to research projects, and these are examples of activities that we've done in some of our projects. This collision avoidance video, for example, the sensors are surrounding the worker, although they're not visible in the video, so that it is able to detect where the worker is and react accordingly, automatically adapting its path to react. And on the other side, we have augmented and mixed reality. So you can see the robot's digital twin in 3D and interact with it while the robot acts in the background. The Asset Innovation Arena was a project which was set up between Högskolan Skövde, the Science Park, Volvo, and the Industrial Development Centre here in Skövde. It is a facility built in one of Volvo's old factories, which we have broad access to. Indeed, many final year projects are carried out there. So the facility is intended for a mixture of research, education, allows for demonstrations, either demonstrations of the results of research projects or the demonstration of student projects, or both, where the two are shared. And as you can see in the bottom corner, there is a stage where we are able to conduct presentations for industry, and actually we usually conduct the final year project presentations on that stage. We have a wide number of research partners connected either with the School of Engineering or with these two education programs. This is a selection of them. Some of them might be familiar, such as the Volvo Group or Scania. Others might be a little bit more specific to Sweden, such as Husqvarna, who specialize in tools, and they have a production facility in a nearby town. ABB Robotics is also a world leader in robotics. Our virtual production development research group is actively engaged, as has been seen from this presentation, in developing the technologies for future smart reconfigurable systems. And these education programs have come out of this research group and are integrated with it. We are Volvo's preferred academic research partner. We are a major ABB partner in education and a Siemens academic partner as well. And we invite you to join our programs and learn about the recent advances in industrial automation and decision support. Thank you.